So a cone is a three-dimensional object with a circular or oval base and one vertex. So these are easy to sketch. You start like you're going to do a triangle and then just give it a curved bottom. And if you want to continue that around, you've got your circular base. You can do it sideways, where something like that. You can do it upside down. Well, that one you can just do the whole oval. Well, that's looking a little bit mealy. But we still want to talk about the radius of the cone, which of course will be from the center of the base to the edge. And we also want to talk about the height. So that's the radius. Of course, diameter would go clear across. The height is going to be, again, the perpendicular distance between the vertex. So we talked about the vertex and the base. Now, we would say the center of the base, but again, we can have, now this is a right. All three of these are right cones. You can have an oblique cone. So the way an oblique cone would look is if we were to go something like that, where the vertex is not directly over the base. So a right cone, the vertex is directly over or perpendicular to the center of the base. An oblique, the center is not directly over. Now the height is still going to be the perpendicular distance between the vertex and the base. So even if it's on its side, this is still the height. Now this one, if this is at a right angle, if that's a right angle, then this side would be the height. But we can even get more oblique if we go like that. And then the height would still be, so if this is the radius, this would be the height. So it's still the perpendicular distance between the vertex and the base, regardless of whether the vertex is over the base. So good to know. So now for the volume. Well, if you'll remember, the cylinder volume was capital BH. Well, do you remember how the pyramid related to the prism? If you'll remember that demonstration of filling up the pyramid, how many times to put it in the prism? Well, the same concept is true of the cylinder. It is 1/3 capital BH. And again, capital B refers to the area of the base shape, and H refers to the height of the pyramid, or sorry, in this case, cone. And it's going to be 1/3 of that. It would take 3 cones to fill up a cylinder of the same radius and height. So let's do a couple of problems. So let's do the red one first. If you'd like to try it yourself before I solve it for you, pause the video and try it. Now, one thing that I noticed that I didn't do for you is I didn't write the volume of a cone. I gave you the volume of anything with a base and a vertex. What I mean by that is I didn't replace the capital B with pi r squared, which I could have done. So when I write my formula for this cone, I'm going to write volume equals pi r squared h divided by 3, because that's actually how I calculate it. Even if I write 1/3 pi r squared h, I still do pi r squared h and then divide by 3. So let's put in the numbers we're going to use. 3.14 times 5 squared, which will be 25 times 4. So really I can see that's 100. So already mental math wise, I can see that the top is 314 divided by 3. And that comes out to be 104 2/3. That's 0.6 repeated. You could round it to 104.7, 104.67 cubic meters. But why when I can just write 2/3, right? Now the blue one, do you notice that I've given you a bit more of a challenge? Did I give you the radius? Did I give you the height? You're missing the 2 things you need in order to find the volume of this cone. So, but again, if you'd like to try it on your own, pause the video. But what I need to do is find the radius and the height. Now the radius isn't difficult. I divide the diameter by 2, and the radius is going to be 5 centimeters. The height, though, hopefully you see this right triangle. Really, I have a hypotenuse. The side of the cone is the hypotenuse, and then the length is 5 of that, or the base of the triangle. Now, yes, you could use the Pythagorean theorem, or if you recognize it, this is one of the Pythagorean triples. And that's the way in which I did make it a little bit easier for you, is I gave you a Pythagorean triple. So the height is 12, the radius is 5. I'm going to write out the formula, pi r squared h divided by 3. So 3.14 times 5 squared, again, happens to be again. Well, I wanted to give you a Pythagorean triple. Times 12, make sure that you don't accidentally multiply it by 13, and then divide by 3. Does it surprise you that the volume comes out to be an even 314 cubic centimeters? And my answer is no, because I see that 12 is 4 times 3. So if I cancel the 3 on the bottom and the 3 on the top, that is 4 times 25, which is 100, and 100 times 314 is, or 3.14 is 314. So something else I'd like to do is, what if we wanted to keep this same volume, 314, but I wanted a cone that was 15 centimeters? What would the radius need to be? So now I've got volume, pi r squared h divided by 3. But now I know the volume. It's 314. Pi, we're going to use 3.14. The radius I don't know, so I'm going to leave it as r squared. The height this time is 15 divided by 3. Now one thing I can do is start by undoing the division by 3 by multiplying both sides by 3. And that equals 942. And that's, and I might as well do 3.14 times 15. So that's 47.1 r squared. So divide both sides by 47.1. And that comes out to be 20. Exactly, that's kind of nice. And that equals r squared. And now I need to square root both sides. Now I can estimate the square root is between 4 and 5, right? 20 is 4 more than 4 squared and 5 less than 5 squared. So right around 4.4, 4.5. And that came out to be 4.472 ... So approximately 4.5 centimeters would be the approximate radius. Now if we wanted diameter, we would just double that number, right? Let's keep the same volume, and this time say that what we want is a cone with a diameter of 15. Let's just change colors. So now the diameter equals 15 centimeters. Well, first of all, that means that the radius equals 7.5. So what would the height be? So volume equals pi r squared h divided by 3. And the volume r I already know to be 314. Pi is 3.14. The radius this time is 7.5. I don't know the h yet, and divide by 3. So again, I'm going to start by undoing the division by 3, by multiplying both sides by 3, and we already know that that turns out to be 942. And this time I'm going to go ahead and multiply 7.5 by itself, or square it, and then multiply that by 3.14. And that equals 176.625 h. So now all I need to do is divide both sides by 176.625. And I got exactly 5 1/3 centimeters for my height. But just recognize that you can go either forwards or backwards